Streams are highly visible features of the landscape that we value and around which we congregate for transportation, water supply, and recreation. We think of streams as features on a map that stay put in their shape and path. We may even designate stream channels as property boundaries. But in fact, streams are constantly changing. The energy of the stream and the ways this energy is dissipated are the causes of changes to its shape and path. Here at Cornell University's Environmental Fluids Teaching Lab, we have created simulations of how streams change as they flow. This long, nearly straight stream has a low flow that is contained within its banks most of the time. Natural events, such as heavy rainfall, a tree falling into a stream, storms, and annual snowmelt, can all change the way a stream behaves, and can change its path and shape. Streams can overtop their banks. They can move or reshape their channels. They can carry along rocks, branches, trees, and soil. In addition, man-made structures, such as crossings, culverts, and armoring, can change the way a stream behaves. Let's look at why this happens. The slope, or topography, of the stream bed, as well as the volume of water or flow, determine the stream's energy. Water has stored energy based on its elevation, a result of the energy needed to move it to that location via rainfall or snow. For example, water behind a dam, at the top of a cliff, or higher on a hillside or slope, has higher stored energy, also known as head, than water at a point lower on the hillside or at the bottom of a waterfall. As water flows downhill because of the force of gravity, some of its stored energy is converted to moving energy, also known as kinetic energy. You can feel the effects of moving energy when you stand in a stream. The moving water tugs at your legs. That kinetic, or moving energy, can be transferred to anything in the stream's path. It can knock down someone standing in a waterfall, carry soil and rocks downstream, or the stream's energy can be converted into electricity, for instance, at a hydroelectric plant. Water released from a higher elevation will have greater kinetic energy and will flow faster than water released from a lower elevation, other conditions being equal. Some of the stream's energy also will be lost to friction as the water flows over rough surfaces or through vegetation. For the same change in elevation, the steeper sloped stream bed will be shorter and lose less energy to friction. Think about the energy of a skier zooming down a black diamond slope, compared to a skier gliding down the gentle slope of a beginner run. The black diamond skier generally starts at a higher elevation, so starts with more stored energy, and by skiing straight down the slope, takes a shorter path and loses less energy to friction between the snow and skis. One of the ways a stream gains energy is when more water flows into it during a storm or from snowmelt. Then, by physical laws, the stream must spend some of that energy as it moves. Within the stream, the energy of the flowing water may be spent by washing or eroding soil and rocks from the stream banks, or by lifting them from the stream bottom and carrying them along in the channel. When a stream removes soil and rocks from the stream banks, the stream channel will begin to form curves or meanders. Water on the outside bank of the meander has a longer path to travel than water on the inside bank, so it moves faster on the outside. Think of a racehorse on the outside having to run faster to keep up with horses on the inside rail. Watch these horses performing the wheel. The ones on the outside have to run or jog to cover the extra distance, while the middle ones move very little. Here you can see that sand is being washed from the outside bank because the faster moving water has enough energy to erode the bank. Along the inside bank, the water is moving more slowly and doesn't have enough energy to carry its load of sand. Here, sand that was lifted by the current upstream is being dropped out of the water, It's being deposited. This is the way that stream channels move from their previous locations. The energy acting on the soil, sand, and gravel, making up the stream bank and stream bed, also acts on other objects within the stream channel, such as trees along the stream bank and man-made structures. The erosion of stream banks and stream beds is a natural process that causes flowing water to lose some of its energy. The stream controls the banks, not the other way around. By living close to streams, we expose ourselves and our property to the force of the water flowing in the stream, particularly during flooding. Understanding the structure of streams during low flow and during flooding is necessary to help us avoid injury and property damage. In this stream, we see a long, straight channel with the flow contained within the banks of the stream. This is generally called low flow. Here, the level of water in the stream has risen to the top of the banks, also called bank full. The effects of the force of the water are still within the channel, although the channel may move some with erosion. Now the water in the stream has overtopped the banks and is spreading out across an area of land on either side of the stream channel. This area of land is called the floodplain. The floodplain varies in width and height along the length of a stream, but its function is to reduce the energy of the water flowing in the stream channel by spreading it over a larger area. Friction between the flowing water and the stream banks, including vegetation on the bank of the stream and in the floodplain, helps to slow the flow of water. Slower moving water has less kinetic energy, therefore is less able to carry sediment, so sediment is deposited in the floodplain. The soil of the floodplain also absorbs some of the floodwaters, and then releases this extra water slowly after the flood recedes, usually over several days. One effect of the floodplain is to reduce the peak of the flood, or the highest amount of water moving through the stream during the course of a storm. This reduction has impacts downstream and may alleviate flooding downstream. As the water recedes, we can see the stream structure again. The edges of the stream channel, the banks and the extent of the floodplain, as well as the vegetation that increased friction and helped slow down the water. During low flow, it can be very pleasant to live on the edge of a stream. During a flood, it is much safer to live on higher ground, beyond the floodplain. The common practice of building in the floodplain reduces its natural ability to mediate high flow events.